When studying astronomy, scientists needed to find a unit for the long distances in outer space. When looking at the night sky, have you ever wondered how far away a star is, or what unit of distance would you use to measure that distance? Astronomers developed a way to calculate distances in outer space by using reference points. Have you ever heard of the word parsec? It is a combination of the word parallax and arc second. It was developed by a British astronomer, Herbert Hall Turner, in 1913 in order to make it easier for astronomers to calculate distances in outer space. Today, the primary use for the parsec is to measure distances between the Earth and the stars and/or between galaxies. One parsec is about 3.26 light years, as they say. Oh, do you know what light year means? For most space objects, we use light years to describe their distance. A light year is the distance light travels in 1 year. 1 light year is about 6 trillion miles. Light travels at a speed of 186,000 miles per second. Looking back in time, when we use powerful telescopes to look at distant objects in space, we are actually looking back in time. This seems really fast, but objects in space are so far away that it takes a lot of time for their light to reach us. Our Sun is the closest star to us. It is about 93 million miles away. So, the Sun's light takes about 8.3 minutes to reach us. This means that we always see the Sun as it was about 8.3 minutes ago. The next closest star is Proxima Centauri. It lies at a distance of about 4.3 light years. So when we see this star, we're actually seeing it as it was 4.3 years ago. Moving forward, let's deal with the brightness of stellar or celestial objects. At the night sky above Earth shows that some stars are much brighter than others. However, the brightness of a star depends on its composition and how far it is from the planet. In astronomy, the measurement of the brightness of a star or other celestial objects is called magnitude. For example, from Earth, the planet Venus appears brighter than any stars in the sky. However, Venus is really much less bright than stars. It is just very close to us. Conversely, an object that appears very faint from Earth may actually be very bright but very far away. Another example, the apparent magnitude of the Sun is negative 26.7 and is the brightest celestial object we can see from Earth. But if the Sun is 10 parsec away from us, it will not be as bright as we see today. For us to understand further, ancient Greek scientist Hipparchus introduced the magnitude system used to measure stellar brightness. Note that an object's apparent brightness depends on its distance from us. So, the magnitude of a star depends on distance. In this system, if a star is precisely 10 parsec away from us, its apparent magnitude will be the same as its absolute magnitude. If the star is closer to us than 10 parsec, it will appear brighter than if it were at 10 parsec. So, its apparent magnitude will be smaller than its absolute magnitude. Lastly, if the star is more distant than 10 parsec, it will appear fainter than if it were at 10 parsec. So, its apparent magnitude will be larger than its absolute magnitude. Next is celestial cartography. Celestial cartography, also known as uranography or star cartography, it is the area of astronomy that produces star maps. Most are aware of cartographers who made early and more recent maps of Earth. Both types of cartography were difficult in early history. Another way of showing the brightness of a celestial object is through planispheres. A planisphere is a type of a star chart that can be said to show the location of objects in the sky for any given date and time. The printed planispheres and charts use different sizes or dots to represent the object's brightness. The charts, maps, and applications show the object's apparent magnitude. And when we say apparent magnitude scale, it is based on what we see and does not truly compare a star's true brightness to other stars. Now, as we deal about stars, do you know that hotter stars are whiter and cooler stars are redder? Our last topic would be all about star color. Look at the beautiful picture of the stars in the Sagittarius star cloud. The stars show a multitude of colors including red, orange, yellow, white, and blue. As we have seen, stars are not all the same color because they do not all have identical temperatures. This image, which was taken by the Hubble Space Telescope, shows stars in the direction toward the center of the Milky Way galaxy. The bright stars glitter like colored jewels on a black velvet background. The color of a star indicates its temperature. Blue to white stars are much hotter than the sun, whereas red stars are cooler. On average, the stars in these fields are at a distance of about 25,000 light years, which means it takes light 25,000 years of traverse the distance from them to us. And the width of the field is about 13.3 light years. So, that's it everyone. Thank you for watching.